Let's work on some junk. What we're going to be working on today is this PC board, and you can say it's pretty badly damaged. Some kind of catastrophic failure in the middle of the board. Normally you see this in the heater relays, but this is above the one heater relay, but it might not be. Let's get it apart and see what's wrong with it. We had a failed heater relay on this board. These relays over time, points in them get dirty and they develop a lot of heat. As they're operating, and it gets so hot that it melts the solder joints that hold it to the board. What we're going to do here today is see if we can get this one apart, see how bad it is, and see if we can make the board work again. It's pretty catastrophic damage on it. See if we can get this see if we get these relays desoldered here and see just how bad the board is. You got to use, they use a high temperature solder on here, and to get it liquid enough to suck off of there, a lot of times you got to use a lower temperature solder. So it's just some cheap 60-40. I usually use lead free when I'm soldering stuff back together, but 60-40 works real good for creating a situation where I can actually get something apart. My desoldering tool doesn't want to stay closed here. So it's got a hair trigger on it. That pin's pretty clean. See if we can get this other one clean. See if we can get it all the way clean. Get a nice hole there with the relay out. We'll come back to him. There's some heavy plating on his board, so it takes quite a bit of heat to desolder these. Oh my God, this desolder tool's driving me crazy. It's got a hair trigger. It's not working that great today. The other ones are trashed. I think I need to buy some new ones. If I stop touching my stupid iron to it. Alright, they're both nice and clean. So this pin's completely gone. Let's see if we can get this one loose. The relay ought to just fall out of here once we get that done. Get her nice and melty. The extra solder on there helps melt out the other stuff. Clean the tip out there. Just want to work this puddle around. Might have put a little too much solder on here, but all the solder I've got on here is going to help melt the other solder. This plating is very thick. Sometimes I just take a toothbrush if I have one handy and just brush that stuff away. Have some wick somewhere too, but don't ask me where. Yeah, I got a little carried away with the solder puddle I made here. I'm gonna suck all that stuff up so I can stop dealing with it. Almost there. Looking pretty good. Let's see if that relay's ready to come loose yet. See if that relay's ready to come loose here. Yeah. Got like one signal pin holding it in. And after you pull the relay off, you want to check the back of it to make sure you didn't pull any plating off the board or little furrows that go through the board. So there's the relay. She's pretty tore up from the floor up. I got the burned up relay off. You can see it's got some plating damage on the board there. I've gone ahead and powered it up, and I'm getting no comm to the top side, which that ain't good. That means that the board is not sending any information to the top side. Let's see if we can figure out why. There is no way to get into the microcontroller of these. It's proprietary. It doesn't use a language like Python or C++ or anything like that. They use their own specific language. They do run RS-485, and if I had, I think it's called a TTL, I could listen to that RS-485 with an Arduino and send commands and intercept it, the pulse widths, and make it do stuff. I don't think it's communicating at all. I don't think there's anything coming out of that RS-485 port. I don't have an oscilloscope here, so I really can't tell if there's any data being sent or not. We're just gonna poke around and see what we can figure out. Okay. Jet pump 1 relay is closing. Jet pump 2 relay is not installed. It takes an auxiliary relays off the board. We have control the temperature circuit, and the light goes on and off. When we first turned it on, it wouldn't come on at all, and I found it had 2 bad transistors and a blown capacitor. I did that off camera because it's down in there, and I don't have the equipment to film it, so I had the components. I just went in and soldered them in, and she turned back on. Cleaned the board up. You can see the damage to the plating and everything. I think we can actually still put a relay in there and make this a usable board. I'm going to show you how. She's leaning against my tripod there. This is going to be our solution, is this T90 relay right here. If I get it out of the bag. You notice the ones that are on the board, they didn't have flag terminals on tops of them. These do. It's the same relay. This just has flag terminals. This one doesn't. And that's how we're going to make this work. We're going to put the relay back where it was. The plating on the supply side where it gets its power from is good. The plating where it sends power to the heater is bad. But we have this flag terminal right here which connects to that pole, so we can actually just run a jumper from here to here. And it'll work. We'll flip this over. I think my soldering iron is still hot. No, let me turn it back on. Get rid of this cable real quick. It's getting on my nerves. Flip this guy over. I'm going to kind of do it bass backwards so that you guys can see. Looks like all our holes are pretty clean. Should be able to just put the relay right in there. All right, relay's in there. We can keep it in there. We'll bend one of these poles over a little bit. Just to create a little bit of friction to keep it in place. This isn't normally how I would do this, so I'm just trying to do this so you guys can see what's going on. All right, stay. Just stay for 2 seconds, please. It takes a long time. This plating is very thick. What I normally do when I'm soldering these back on is I start out here away from the pin, and I just kind of work my way into the middle, a nice hot puddle of molten solder, and then I'll, ooh, this sucker's hot. I think I gotta take it out of your line of vision here for a second, so I can make sure that lays nice. Okay, so that pin soldered in real good. Looks good. I'm going to go ahead and solder these two in. Push that relay belt where it goes. Okay, those pins look good. Let's see what we can do with this over here. I want to have some connection to this pin, but this plating's damaged so bad, I think we'd probably just take a little wrap of wire and wrap it around there and solder to that plating. will have some connection there. Like I said, we're not going to be relying on that to be our only point of connection. Oh, this is some fancy wire. This is like tinned wire. I'm just going to lay that on there like that. But, you know, I'm going to put it underneath of this green wire. Let it be a clamp for me. There we go. Finally getting hot enough. Oh yeah. That's just like one continuous blob of solder now. Go ahead and cut the excess off of here. It's the smallest pair of end cutters I can find. I don't know where all my little ones are. Just a barbarian. Alright, that's done. Now, on this side, what we're going to do is we're going to run a jumper from here to here. And that is going to bypass that plating and give us power to the heater. I will probably not ever resell this board or install this in a customer's unit. This is kind of just for fun today. Stripping a little wire here. Yes, I'm going to go ahead and use my crimpers wrong. I know that this is for the insulated, but I just don't trust it. I don't trust that flat crimp. I like the W crimp. And even though it's insulated, it's still crimping the metal inside. Let's go ahead and this guy here. Go ahead and hook that guy there. So now we've bypassed the plating that was damaged on the board by doing that. This with probably be safe if you install this with a 4 kilowatt element. That's only about 16 amps. Yeah, I definitely wouldn't install this unit, this board, and I would never install this again. I definitely wouldn't install it with a 5.5 or 6K heater. You're asking for too much. Here's what we're going to do. We're going to grab this meter, and this is going to emulate our heater. We'll get them in there real good like. It's actually open up, so let's open them up. There we go. All right, so we're good. Got that in there, that in there. We're going to grab another meter. We should have one right here. And this is going to emulate pump 1. Which is right here. So this should be the common. This should be this ground. This should be common. Which I'm actually just going to go ahead and jam in here, because the tip's broken off of that probe. And go ahead, turn this meter on, Go turn the power on. We're back. The board is wired up, and I've got this meter is going to emulate the heater. This meter is connected to low speed on a jet pump. Or this pin right there. There you go. So jet pump 1's on. If I hit jump pump 1 again, it should switch to high speed, which should turn the low speed off. There you go. So that's off. Now the heater is not on. The way that works is it takes about 4 minutes for the heat to boot on. And because this heat light right here is going to flash, it's going to strobe, and it's going to turn the heater on for just a second. After that, it's going to turn the heater off, and it's going to probe these 2 sensors. Got one here and one precariously under the control, maybe shorting things out. And that just happened. So the heat's on, it's going to turn back off in a second. Now what's happening is the computer seeing if there's too big of a differential between these two, because one of these sits right over top of the element, and the heater will decide whether water's flowing or not. If it's not, it'll shut the unit off. It'll say low flow or overheat. So you see the way that heat light is strobing? So we have ourselves a working board. And let's turn the light on. Woohoo! Light turns on, light off, light on, light off. Can't test pump 2 because it goes to an auxiliary panel that hooks up right here, I think. Yeah, I think it's the auxiliary. It might be up there. Anyway, use the auxiliary relay that I'll have hooked up right now. I might have one in the truck. So what we're going to do now is wait for this thing to stop polling. And it's saying the current temperature is 83 degrees, which is about what it is. End of September, September 20th, 83 degrees. And once it's satisfied that the unit's not overheating, it should allow the heater to turn on, and it still says that the low speed pump is running. I might have to cut this. There we go. So now the heat just turned on. Now, depending on how it's hooked up, the heat may shut off if I turn on Jets 1 high speed or Jets 2. So this is set for high amperage. We can just change a switch right here. Very good. We've got a working board from a board that was completely trashed. There she is, back inside the case. Get the heater reinstalled. Put the cover back on.